All right, today we are going to be looking at another way to solve quadratic equations by a method called the square root method. So first, quick review on the way we used to solve. We learned previously was factoring. So when we had standard form, everything was on the left, it's equal to 0. First we look for the GCF. And then this expression can't be factored further, so we set each piece equal to 0 to solve for x. So we get that x is 0 or x is positive 3. So those are our two solutions on number 1. Looking at number 2, I need to get this where everything is on one side and it's equal to 0. So I'm going to have to expand it out. So I have to FOIL on my left side. And then because I have the plus 2 and the minus 2, that's going to cancel my middle terms, and I'm just left with minus 4. And now I'm ready to combine my terms. So I'm going to add w squared to both sides. Subtract 26w. I don't have any of that on this side, so it's going to stand alone. And then add 16, and that gives me 12. So I have everything on the left, and I'm ready to factor. First I look for a GCF, and I have one of 2 here. And that leaves me with a trinomial in the middle. And my coefficient on the squared term is greater than 1, so I'm going to have to do my splitting the middle term. So a times c is 30. Factors of 30 that add to negative 13 are negative 10, negative 3. So rewriting this, that 2 stays in the front. Now I group and I group. So that 2 is still in the front. That should be a 2, not a 5. 2. So w minus 2 is my common factor, and that leaves us with 5w minus 3. So now I'm ready to solve. Set each parentheses equal to 0. And I'm going to get 2 or 3/5. So all that is review. Now looking at our new way of our square root method, we have 3 steps to take care of. The first is to isolate the square on both sides. So we either need to have x squared or a binomial squared. And then we're going to take the square root of both sides, and we're going to take the positive and negative roots. So remember, 3 squared is 9, and negative 3 squared is equal to 9. So that's just an example of how when you square a negative number, you still get a positive answer. So when we're taking the square root, we have 2 possible roots, the positive or the negative. So starting with example 3 first, I need to get my root by itself, so I'm going to divide by 25. And so x squared is 16 over 25. It's now alone, so I've done step 1. Moving on to step 2, I'm going to square both sides. And I'm going to get that x is plus or minus the square root of 16 over 25. And the square root of 16 over 25 is 4/5. So that takes care of example 3. On to example 4. On the left here, I have a perfect square trinomial. That's 2x plus 1 times 2x plus 1. So I can rewrite that as 2x plus 1 squared. So I have my square term already isolated, and I'm ready to take the square root of both sides. So 2x plus 1 is going to be plus or minus the square root of 50. Now 50 is not a perfect square, so I have to simplify this radical. So I'm looking for factors of 50 that are perfect squares, and that would be 25. So I can take out the square root of 25, which is 5, and the 2 stays inside the radical. Now, I need x by itself. I'm still trying to solve for x, so I have 2 more steps to take to get x by itself on the left, and that's going to be to subtract 1 first. And then similar to how we have a standard form for our complex numbers, when we have radicals that we can't combine, we want to leave the whole number in the front. And then we just also now need to divide by 2. So x is negative 1 plus or minus 5 square root of 2 over 2. Couple more examples. On number 5, I need to get my my square by itself, so I'm going to subtract 12. And then I can square root both sides, and I'm taking the square root of a negative. So we need to rewrite this in I form. So that's going to be plus or minus the square root of 12i. Now 12 is not a perfect square, so I need to find factors that are, and that's going to be 4 times 3. So I can take out the square root of 4, and the 3 stays inside the radical. Number 6, my square is already by itself. So again, took the square root of a negative, so I'm going to rewrite that in I form. Now, I still need to get x by itself, so I have to add 6 to the other side. And remember, with a complex number, the real number goes in the front. Okay. On to another one. Now, this is a slightly different type of problem because we have a higher order exponent, but we can still factor this because it's a trinomial. So that's going to be x squared and x squared. So now I need factors of negative 4 that add to negative 3, and that's going to be positive 1 and negative 4. Now, this cannot be factored further, but x squared minus 4 is a difference of squares. So that's going to be x plus 2 times x minus 2. So I've factored completely, and I'm ready to set up my parentheses equal to 0 to find my solutions. So x is going to be positive 2, x is going to be negative 2. Oh, and now here I have to take my square root method. So I'm going to move that 1 to the other side. And what do you know? I'm taking the square root of a negative number. So that's going to be plus or minus the square root of 1i. The square root of 1 is 1, so this is going to be plus or minus I. So I have 1, 2, 3, 4 solutions. All right. Now this is a problem we have done the day that we did our first factoring to solve quadratic equations notes. So we are given the solutions, and we're going to work backwards to find the quadratic equation that it originated from. So remember, our last step when we're solving for x is we are originally having an expression equals 0. So we want to get back to that expression. So if x equals 1, if I subtract 1 from each side, that'll be 0. And if x equals 2, if I subtract 2 from each side, that'll be 0. So these expressions were what would have been inside of my parentheses. So x minus 1 times x minus 2. And now if I FOIL, I'll get my quadratic. So I can combine my middle terms, and there is my final answer. So number 8, same deal. I want to get back to being 0. And I have my 2 expressions that were inside my parentheses. Now, we don't like having fractions inside of our parentheses when we have factored, so we want to make this a whole number. So if I multiply my entire equation by 4, that fraction becomes a whole number. So here's what's going to be inside my 2 parentheses. X plus 2 times 4x minus 1. And then I FOIL. And combine my middle terms. And there's my answer. Okay, last one. And this one's a little bit trickier, but we're going to be using the same process. So I want to get these back to being equal to 0. So on the first one, I'm going to subtract 3 and the square root of 2. And on the other one, I'm going to subtract 3 and add the square root of 2 because of opposite operations. So this is what's inside of my parentheses. So x minus 3 minus the square root of 2, x minus 3 plus the square root of 2. Now, when we got to this step in the previous ones, we just FOILed to get back. But this one would be a lot trickier to try to FOIL. So let's take a closer look at what we have here. I have x minus 3 and x minus 3. Oh, and sorry, this should have been the square root of 2. I have x minus 3 minus the square root of 2 plus the square root of 2. Now, if we think back, when we factor the difference of squares, it's a minus b, a plus b. So this could be the factored expression for a difference of squares, where if a had been x minus 3 and b was the square root of 2, we would have factored it in this manner. So if I, instead of trying to FOIL and combine like terms, I just go back from the factored form to the original difference of square, a squared minus b squared, that would just be x minus 3 squared minus the square root of 2 squared. And if that's equivalent to 0, sorry, I'm running out of room, so I'm trying to find a blank page. So I can FOIL this, and then when you square a square root, the radical goes away. So I can combine my constants, and here is my final quadratic.